NASA is watching something in space. Not once, not occasionally, but constantly, day and night, without interruption, and that alone should make you uneasy. Because NASA does not monitor anything continuously unless there is a reason. A serious reason. Right now, telescopes, sensors, and supercomputers are locked onto the same region of space. Data is updated, trajectories are recalculated, risk models are rewritten. This is not curiosity, this is precaution. And if you're wondering why most people have never heard about this, you're already asking the right question. Stay with me. For decades, NASA has tracked objects in space. Asteroids, comets, solar storms. That is normal. What is not normal is when one specific object, or region, requires uninterrupted monitoring. When scientists refuse to take their eyes off it. Because this time, the concern is not theoretical. It is mathematical, it is statistical, and it is uncomfortably real. The object being monitored is classified as a near-Earth object. That term sounds harmless, almost boring, but it shouldn't. Near-Earth objects are bodies whose orbits bring them dangerously close to our planet. Close enough that even small changes in trajectory can matter. Very much. In the past, scientists believed orbits were stable and predictable. You calculate once, you verify, you move on. That confidence is gone. Modern data revealed something unsettling. Space is not clean, it is not empty, and it is not quiet. Gravitational forces overlap, solar radiation pushes and pulls. Even tiny interactions can alter an object's path over time. And here is the uncomfortable truth. A deviation that looks insignificant today can become catastrophic years later. That is why NASA keeps recalculating. Again, and again, and again. You might hear scientists say the probability is low. That phrase sounds comforting. It shouldn't. In planetary defense, low probability does not mean low risk. Because when the outcome involves global consequences, even a fraction of a percent becomes unacceptable. Imagine boarding a plane knowing there is a small chance it will not land. You would not call that safe. NASA doesn't either. This is why monitoring never stops. Not because impact is guaranteed, but because uncertainty exists, and uncertainty is dangerous. There was a moment, rarely discussed outside scientific circles, when updated calculations forced NASA to quietly adjust internal risk models. No dramatic announcement, no headlines, no public panic, just silent revisions, more simulations, more observation time, more attention. That is how real concern looks in science. Quiet, methodical, urgent, and while the public assumes Earth is well protected, the reality is more complicated. Yes, we can detect threats earlier than ever before, but detection is not prevention. Deflection missions are experimental. Response windows depend entirely on how early an object is detected, and some trajectories offer very little time. Sometimes, only years, sometimes, less. That is not a comforting margin. NASA's monitoring is not passive. It is active, relentless, because the worst-case scenarios do not allow second chances. And here is something most people never consider. An impact is not just an impact. It is seismic shockwaves, atmospheric disruption, climate consequences. An ocean impact could generate tsunamis crossing continents. An atmospheric explosion could alter weather patterns. A land impact could inject dust into the atmosphere for years. Scientists do not just ask where it would hit. They ask what happens next. And some of those answers are deeply unsettling. This is why NASA models chain reactions. Not just the event, but the aftermath. Food supply disruption, infrastructure collapse, global economic shock. Even a regional event can become global very quickly. So why isn't this discussed openly? Why does most of this information live inside technical papers and internal briefings? Because fear without context creates chaos. And because probabilities change, sometimes slowly, sometimes suddenly, and when they do, preparation matters more than headlines. Right now, the probability is considered low, but it is not zero, and that is enough to justify non-stop surveillance. If you are still watching, pause for a second. Subscribe, because this channel exists to explain what most people are never told, calmly, clearly, and without distraction. In the next part, we are going deeper. You will see what emergency protocols actually exist, what scientists privately admit about our limitations, and why the real danger may not be the object itself, but our reaction to it. If something were truly on a collision course with Earth, what would happen first? Sirens? Public warnings? Emergency broadcasts? No. The first thing that would happen is silence. Because real emergency protocols do not begin with panic. They begin with verification. NASA has layers of response plans. Most people never hear about them, not because they are secret, but because they are technical, conditional, and deeply unsettling. Every scenario depends on three factors: size, speed, time, and time is the most unforgiving variable of all. If an object is detected decades in advance, there is room to act. Deflection missions can be planned, trajectories can be nudged, risk can be reduced, but if detection happens late, options disappear very quickly. And that possibility keeps scientists awake at night. Contrary to popular belief, there is no giant planetary shield. There is no guaranteed way to stop an incoming object. What exists instead is a chain of probabilities. And probabilities are not promises. NASA has already tested deflection. The DART mission proved something important. Humanity can change the orbit of a small asteroid. That sounds comforting, but it also revealed a limitation. The success depended on timing, size, and simplicity. Not every object is cooperative. Some spin irregularly, some are loosely held rubble piles. Some react unpredictably to impact, meaning one solution does not fit all. And here is the part most people never consider. Deflection itself carries risk. Change in orbit too much, and you might move the threat, not eliminate it. A near miss can become a future hit, which is why NASA models outcomes years and decades ahead, not days. Now imagine a scenario with limited warning. Not decades, years, or worse, months. At that point, the question is no longer prevention. It becomes mitigation. Mitigation means impact preparedness, evacuation modeling, infrastructure stress tests, supply chain simulations. Governments quietly ask questions no one wants to answer. Which regions are most vulnerable? How many people could realistically move? How long would recovery take? Some answers are uncomfortable, some are terrifying. This is why transparency becomes complicated. Because telling the public too early can cause panic. Telling them too late removes choice. There is no perfect moment, only calculated risk. Scientists understand something most people don't. Fear spreads faster than facts. A single misunderstood headline can destabilize economies, trigger mass movement, collapse trust. So information is released carefully, slowly, measured, but even with caution, there is a hard truth. Earth has been hit before. Many times. History is written in craters. Mass extinctions are not theoretical. They are documented. The difference now is awareness. For the first time, humanity can see threats coming. But seeing does not guarantee control. Some scientists quietly admit this. If a large enough object appeared with insufficient warning, there may be very little we could do. Not because of incompetence, but because physics does not negotiate. This is why NASA monitors relentlessly. Not because disaster is certain, but because ignorance is unacceptable. There is another layer to this story, one that rarely makes it into public discussions. False alarms. Several times, objects initially flagged as dangerous were later downgraded. Recalculations saved humanity from panic. But those moments revealed something important. How close uncertainty can come to catastrophe. A tiny error, a missing data point, a delayed observation, all of it matters. This is why constant monitoring exists. Not to scare, but to refine, to narrow margins, to reduce unknowns. Still, the most unsettling question remains. What if something appears without warning? A fast-moving object from a dark trajectory, approaching from the direction of the sun, invisible until it is too late. Scientists have modeled that too, and those simulations are rarely shared publicly. Because in that scenario, there is no hero moment, no last-minute save, only response, only survival strategies. This is why planetary defense is not just about space. It is about psychology, coordination, trust, and this brings us to the most uncomfortable truth of all. The real danger is not always the object. It is how humanity reacts. History shows this clearly. Societies under stress do not behave rationally. They fragment, they hoard, they turn inward, which is why preparation must be quiet, methodical, unemotional. NASA understands this, so does every major space agency. That is why cooperation exists behind the scenes. Shared data, shared tracking, shared contingency planning, because no country owns the sky, and no border stops an impact. Right now, nothing is classified as an imminent extinction threat. That matters, but it does not mean the risk is gone. It means the watch continues. And one day, that monitoring might detect something different. Something that shifts probabilities, even slightly. When that happens, the world will not change overnight. It will change quietly first. In calculations, in simulations, in meetings you never see. Then, if necessary, the public conversation will begin. Carefully, deliberately. Until then, NASA keeps watching. Not out of fear, but responsibility. If this video made you uncomfortable, that is not an accident. Awareness is uncomfortable, but ignorance is worse. If you want to keep understanding what is happening beyond the headlines, subscribe. Because the universe does not ask for permission, and knowledge remains our only real defense. And now I want to hear from you. Do you think humanity is truly prepared for a real cosmic threat? Or are we still relying on hope more than readiness? Leave your answer in the comments.